So as Cameron mentioned, yeah, this will be recorded. Hopefully that is okay with everybody. And as we get our slides going, are they set up? Are they looking good?
Looks like we're seeing the presenter view if you want to swap the screens.
All right. Nope.
While Jordan is getting set up,
Mm.
I saw a question in the chat. Yes, this recording will be posted on HeroX after the fact. And if you do not wish to be part of the recording, please just stay silent and post any questions you have in the chat. Thank you.
All right. Nothing like starting off a little technical difficulties. We got to figure it out. Great. All right. So how about we dive into this right now, because I think what we really do want to get into is the Q&A, see what kinds of questions and kinds of issues people would like to discuss further. Here's an overview of the agenda of some of the topics we'll go through in this webinar. And again, with our hope that most of our time is spent in the Q&A portion. So as has been mentioned, this webinar is going to be recorded. So you'll have access to the webinar as well as the slides afterwards. And you can always feel free to reach out to us. Any questions that we do not get to in this webinar will be responded to, and the answers will be made available. All right. So a little bit about, before we dive in, a little bit about who we are. So the NREL Inspire team has been working on agrivoltaics since 2016. We've worked on a number of different projects all across the country. We've also done technical assistance on, I think we're up to around 30, over 3 dozen projects all across the country doing technical assistance on agrivoltaics itself. We cover a wide array of different types of activities, from modeling to economic analysis to field work, all sorts of different elements. And you can see here, you know, a subset of our team and some of the capabilities and areas of expertise that we bring to this, spanning PV, design and technology, agricultural operations and experience, and everything sort of in between. So you've got a great crew. I'm supported by an amazing team here, and this team is going to be here and available to answer your questions on this call, in our office hours, and going forward as well. So let's do a brief reminder of what we're looking at with the LASSO call as a whole. So what we're seeing is, this is, you know, a pretty exciting $8 million prize award for demonstrating can we do agrivoltaics with cattle operations in the United States. There we have 2 separate tracks, one for people who are developing new projects. Today's webinar might be most interesting for those developing new projects, as well as a second track that's for teams that have existing cattle agrivoltaic projects. Slightly different rules and timeline for each of those tracks, which you can find in the rules section. But I think a lot of the principles are going to apply to both. And both teams, I think, are also eligible for these exciting bonus prizes. So some of the resources for you to be made aware of, the rules are listed here. I think we're also going to have them in the chat to make sure, you know, you follow the rules and make sure you submit an eligible project. Some of the key things I think we wanted to remind people of is that these project systems should be at least 250 kilowatts. Larger systems are obviously desirable, but at a minimum, we'll need to see 250 kilowatts. The cattle must be directly integrated or co-located with the system. Only the capacity of the PV system that the cattle are actively, and actually grazing under are counted towards that 250 kilowatt size. And these projects do need to be interconnected to the grid. So full rules, you can see there. Teams are going to also be a really essential part of this. And so there's some really excellent resources to assist and help you with finding teams. If you're looking for, if you're a developer looking for a rancher, or you're a rancher looking for a developer, check out those, the teaming resources on HeroX. And as a reminder, the date we're all shooting for both tracks is March 6th. So we will have some other events and activities and other support options before then, but really March 6th for both of those tracks are the key dates we're shooting for right now. So if you haven't already, do follow the prize. You can see the submission form, see the FAQs, see other resources there. But it's a really great resource that hopefully you are all already following. Great. Okay. So after that, what we wanted to do before diving into some of the design principles for integrating cattle into agrivoltaic systems, we did want to show just some pictures of existing systems to let you know what has been done. Some of you on this webinar are very intimately familiar with these projects. Others, it might be new. So a first type of system we might see are fixed tilt systems. So you can see the one with the University of Minnesota, another one with the University of Massachusetts. Here we have elevated structures, but these are fixed tilt systems. So no moving parts, but they're elevated, and the cattle are able to graze underneath them. A second type of system that we have seen deployed, both domestically as well as internationally, are with vertical bifacial systems. And so these sort of mimic a fence more or less and are vertical, and cows are able to graze and interact in between rows of them. And here we see one of our examples from our friends at Rutgers University, as well as another site in the Netherlands. And then lastly, another example for what we have are single axis tracking systems, which are elevated, but then these run north-south, and then the panels move throughout the day. So the panels track the sun from east to west, moving throughout the day. You can see, again, the cattle graze underneath them. You'll see on the right our friends at Jack's Solar Garden with cattle grazing underneath their elevated system there. So again, hopefully that sort of gets it in your head. This is possible. This has been done. People are doing this not only in the United States, but also internationally. And so there's a lot we can learn from these existing systems, which have really been pioneers in testing it out. And one thing we're hoping for with this LASSO prize is to really see, how do we scale it up? How do we make this something that works at that larger scale? So let's jump into, I think, the meat of our content today, which are the key design considerations for doing cattle agrivoltaics. So what we've sort of laid out here is a little schematic highlighting some different areas to think about, some different topics and different design elements to think about as you're considering creating an agrivoltaic system that's going to be compatible with cattle and other large livestock. Some of the resources you will see here. You can also find more information out on our Inspire website at the Getting Started new resource. So that's going to be another great resource for people to look at and to digest a little bit more. You're just going to be getting some of the highlights today in this webinar. So starting with our mounting and racking system. So we did give a little bit of a preview of some of these systems with the pictures that I had showed of the existing systems. So what we might see are some what we might call standard designs, which would be those fixed tilt, oftentimes south-facing fixed tilt systems, or the north-south running single-axis tracking systems. that have panels rotating from east to west. There are also a number of emerging designs that could be considered for these systems. One was the vertical bifacial system that I showed that we see at Rutgers as well as internationally. Then there's also canopy designs or other cabled systems that might have a very tall setup that's held in place. So you have a large amount of space underneath these systems without necessarily a lot of the vertical posts in the middle. So with all of these, though, I think one thing we are seeing our major considerations are things related to your system height. So how high are the panels off this? So with many of these systems, you have vertical support structures and then you have horizontal support structures. What is the height of that horizontal bar? And what we've seen are various approaches to this that have often resulted in elevated panels, whether it's 6 feet, 7 feet, 8 feet, 9 feet, 10 feet, to avoid substantial interaction with the animals. Those obviously will come at a cost premium to elevate those panels. This also ties into what we call the ground cover ratio, which is more related to the spacing of your rows. So how far are your rows of panels? Some people might have 20 feet, you might have 25 feet or 30 feet or more of space in between your rows of panels, which obviously the more space you have in between rows of panels, the less shade there will be on the grass underneath, but also the less electricity generation you're going to get per acre of land that you have in production. So with all of these design decisions, whether it's with your racking system, your height, your spacing, we are going to see these trade-offs between capital costs, generation, and maintenance issues. So as an example, for single axis tracking systems, those will oftentimes cost more in terms of your CapEx than a fixed tilt system. They also might have a larger land footprint in terms of capacity, but they will produce more not only per kilowatt installed, but also per acre. But they also might come with some more involved maintenance activities because you do have moving parts. And so I think as we think about the selection of your design, whether you go, what type of mounting or racking system, your height, et cetera, these are sort of the elements that you need to consider. The NREL team here can help with evaluating some of those cost comparisons, as we get into future stages of technical assistance, of comparing what is that install capital cost compared to how much land is it going to take, compared to how much generation are you going to get out of it, and what are the long-term revenue trade-offs associated with that. So as we move on to our next topic, which are PV technology selection and other solar panel configurations, we are seeing with PV technologies there is the opportunity to use monofacial PVs, PV technologies, bifacial PV technologies are able to produce electricity from both sides of the panel, and this can be especially beneficial if you have elevated systems. So there's a lot of reflection that can occur. In the United States, we also have cadmium telluride panels. There's a growing market and those cadmium telluride panels can also have varying levels of transparency or translucency. And there's other emerging technology panels as well you can have that might have, again, varying levels of how transparent those panels could be to allow more or less sunlight to pass through to the ground below. When considering your PV panel configuration, you can think about what is going to be the space in between panels, how much, again, we're going to get into that row spacing as well as that system height. All of those things are really going to affect then your installed costs, but also how much shade is going to be hitting the ground, which is going to affect things like soil moisture. It's going to affect vegetation growth. it might also affect how much shade are the animals able to achieve by going underneath the panels in those systems, as evidence there. And so I wanted to bring, highlight one, simple example that we can use from Jack's solar garden, which I think gives us a good example, because at Jack's there are two different heights. You can see there's sort of a 6-foot panel height where you can see the level of shade from the center of the bed all the way to directly underneath the panels. Under the 8-foot panel arrays, you have a little bit more uniform sunlight. And so not really those same extremes of really bright and really dark, but a much more uniform design. What does that mean for other parameters? Here we can look at some of the great work that Matt Sturcio at Colorado State has been able to do, along with Ellen Knapp and Steve Kannenberg and a handful of other folks, in looking at what is the impact of that shading and those panel designs on things like your soil moisture, as well as your vegetation growth. So here we can see, there's some pretty distinct patterns for this single axis tracking system for where we might have more or less moisture. So we might see a lot of moisture near the panel edge as dew and rainfall drips off that. And that can also then affect where we see more vegetation growth. So for example, near those panel edges versus less, directly underneath the panel, as well as in between panel rows. And so these are all sorts of the considerations that your racking system and your PV panel selection and PV configuration will have. And again, that's what we're showing here, sort of impacts on soil and soil moisture, vegetation growth. You also will have to consider impacts it might have on animal health and shade available for animals. So the next topic we wanted to get into is related to electrical wiring, and this is really has a primary focus on the safety of the animals, safety of the electricity of the PV system, safety of the people working on it. So here there's some pretty strong best practices and recommendations to make sure any above ground wiring that is there is really fully protected. It's in conduit, no dangling loops or no opportunity for any interaction between the animal or humans or equipment with this wiring. And so really the primary focus is making sure there's nothing that could really pose a risk, a safety risk. Similarly, for below ground wiring protection, here is where we do want to make sure that any wiring that is there is really buried at a sufficient depth to avoid any potential interaction with equipment, with any animal behavior, and that this should hopefully stay true depending on changes in weather, changes in land management practices, any other potential activities, or if you need to revegetate an area, if you need to do some scraping or tilling or anything else that you might need to do in order to revegetate or to restore some vegetation, that you're really taking those into consideration from the beginning and making sure there's really zero risk from the beginning. On the O&M side, I think here's, I think it's a good reminder that these systems are, they are agricultural activities, they are agricultural sites, but they also have a lot of energy and electricity equipment on there, which will occasionally need to be replaced, repaired, inspected, managed. And so we do want to make sure that all of that electrical equipment that does need to be accessed for or inspected or repaired, that there's thoughtful consideration going into when those scheduled activities are going to occur, making sure that you have a place where animals can be separate from that, but then also that you don't have equipment that is in an awkward place or that might lead to damage on the ground or in any other way. I think this also relates to, as you come up with the design and develop your teams, your partnerships, thinking about the proper roles and responsibilities for each aspect of the system. And so this is, O&M, not only on the solar equipment side, but also any occasional changes in management techniques or other approaches that you might need to do for managing the livestock on site, making sure there's clear roles and responsibilities defined for each of those, along with clear timelines set up, so you're not trying to do similar incompatible activities at the same time. There are some, available, potentially monitoring control systems that can help. Also with getting real-time information to know if you do have an issue related to your electricity production or any other infrastructure, getting alerts as soon as possible. All right, the next category is our integrating, cattle into the system, and making sure these systems are compatible with our animal operations fully. And so I think things we want to consider are, make sure we think about in the design are any potential temporary or permanent infrastructure from the agricultural side. And so whether these are temporary fences, permanent fences you might want, water basins or troughs, other sorts of other equipment, thinking about, do we have enough space for this? Where am I going to put this? If I do need to get in some larger tractors or other, revegetation equipment, what does that look like? Do I have enough space for that tractor to turn around? All of these things sort of come into play. And so I think detailed consideration of what will you need to manage the cattle. Similarly, we also have to think about all solar infrastructure. So this is beyond just the panels, but if we do have combiner boxes, inverters, other sorts of pads or other types of equipment, batteries, other things that you might have on site, thinking thoughtfully about where those go. Because if you do place some of those boxes, at the end of a field or in between the rows in some way that might disrupt a tractor getting in, free flowing of animals, or you might need to create another fence, that can add additional costs and it can add additional complications to your design. If there's any seasonal changes in animal activities, their behavior, where they are throughout the entire plot of land, I think those are something good to think about from the beginning, including how to accommodate that, how to really make that as seamless as possible. Similarly, what are the types of interactions we might see with cattle? Are they going to be licking this? Are they going to be rubbing their backs? How do we ensure the system is not only strong enough to withstand that, but also, again, minimizing any potential risks. And so not having, sharp or, exposed screws or other things like that could lead to any sort of injury or excessive interaction. If as a rancher, you do anticipate changing the herd size or the breeds or other things that might come up, thinking about how can you design this system so it's flexible enough to handle those changes in both sizes, breeds, or other sort of management practices. We do want to make sure, as we have, best practices already established for managing cattle, that we, any sort of design is sort of aligned with those, and also aligned with any sort of prescribed grazing plan you might have on your site. Okay, one thing we have heard a lot of interest about is, grid tied versus off-grid systems. I think this is very much an issue that, in general, I will say, LASSO does require these systems to be grid tied. But many of you have also expressed interest in off-grid or microgrid systems. This is very much going to be dependent upon local, state, and utility options, as well as policies. It's also going to be impacted by what is your load on site. So if you are a dairy operation, for example, you might have a much higher load than just a wide open land. And so all these things are going to factor into play. That's other elements that NREL does help with technical assistance on a wide array of fronts, which is not necessarily related to agrivoltaics at all, but just based on pure solar development. You also need to think about, okay, what sort of rate are you going to be able to get from selling electricity based on what size system you have, and is there a metering program, et cetera, versus how much more electricity are you producing over your own load. You can also consider battery costs and performance for various types of systems. But interconnection planning, compliance, and cost estimates, I think, are a really important part of LASSO. to ensure that you do have an interconnection agreement to make sure you are eligible to receive this. And I think all these things really tie into insurance, financing, and the business model that you have and your relationship that you are setting up among all various parties. And as a reminder, again, these LASSO projects must be interconnected. Okay, so that was sort of I tried to go through that again as sort of as a whirlwind as quickly as we can, just to to give you sort of that foundation. But we are hoping most of this is most of our time is spent in our Q&A. And I wanted to point again these resources that we have for our agrivoltaics groundwork. And so these are some resources. So these are some things that we feel like are really valuable to do before you ever build your project, before you ever start digging in the ground. These various activities related to working with your community, identifying partners, making sure you are sort of fully representing what could be done, other farmers that could be doing this, exploring financially, doing some training, capacity building, and then sharing what you've learned with your friends and your neighbors and your broader community. I think can be really helpful. And then we also get into our agrivoltaics pathway of actually building the system and various steps along the way. And again, more of those resources can be found at that link there. So with our technical assistance preview, then sort of what to expect. So today we are having our first webinar on really these basics associated with agrivoltaic design and fielding questions. I'm very excited. In 2 weeks, we're having an office hours session. So on January 22nd, we'll have some office hours where we'll be able to take more questions we don't get to today, or other questions that come up in the next 2 weeks. We'll be able to sort of address that. And it'll be our NREL team. So I'm joined here in the room by Alexis Pescaris and Brian Mirletz. Also online, we've got James McCall, Brittany Stay. We've got a wealth of information of people who can provide feedback and insights on any sort of question you might have on this. So, but then you see the other schedule set up for sort of our pre-selection technical assistance. For those of you, for those teams that are selected to move on to the next phase, then you get a lot more one-on-one technical assistance time with the NREL team to do a lot more specific cost comparisons, design trade-offs, looking at a lot of different of these elements and these design considerations that we just talked about today. So, and again, if you haven't already, sign up to be a LASSO competitor, and you'll, I think, automatically get all these insights and all these updates as they come. So with that, thank you very much for your time and patience through that. I would like to open this up to questions, and I think James is looking at the Q&As and the chat. Should we dive into some of these questions?
Sure, absolutely. So I think we're working to answer a few questions kind of offline because they're much more about kind of prize rules. But I think one kind of question that I think kind of popped up is, has there been any feasibility work done on irrigated systems? So basically any pasture systems that actually use naturally irrigated, or basically irrigated pasture systems versus naturally irrigated land.
Yeah, so there have been a number of sites, agrivoltaic sites, solar sites, I should say, just more broadly, that have implemented irrigation, and there's been different approaches to irrigation on these various sites. So we have seen some sites being proposed with basically ground-mounted sprinklers, which are what you might expect in someone's yard, actually. But these are ground-mounted systems that would then pop up and sort of spray water. The second types of irrigation systems we've also seen are overhead systems. So these would be systems that are maybe elevated. They're not necessarily hanging onto the panels, but they're up near where the panels are tied into your horizontal beams, and we have seen those irrigating that way. We've also seen irrigation systems that are using drip irrigation. And we've also seen underground irrigation systems. And so I guess I feel like in many areas, especially out west, to have a healthy pasture, many areas might need irrigation, and many areas are currently irrigated. Something we have not seen so far successfully integrated are center pivot irrigation systems, integrated with solar projects. I think there's a lot of movement. There's a lot of potential for potential stress or fractures on the panels. We haven't seen those, but again, the sort of the ground mounted, the overhead, drip irrigation, and underground irrigation systems we've all seen successfully deployed.
Great. I think a lot of these are much more about the prize rules, so I'll allow kind of anyone to kind of chime in on this. Do the cattle have to be under the panels 100%? We need to rotate our cattle for regenerative farming, so they will have to rotate out from under the panels occasionally. I don't know if that wants to be Cameron or Bryn to answer that one.
Happy to start, and then we'll let you all jump in with the technical answers. But short answer is no, cattle don't have to be under the panels 100% of the time. We're expecting rotation either within the array boundaries or outside the array boundaries, and looking for a plan, a grazing plan and management plan that's going to take the welfare of the cattle on the land into account and prioritize those things.
Any technical things that we want to include in that from the Inspire team?
No, I think the goal here is to make sure that, we are supporting healthy management of cattle, and making sure that teams are following, best management practices. And so as much as that involves rotating, changing locations, et cetera, I think we want to see that. But we know every site's going to be unique. Management practices are different in different areas and for different purposes, for good reasons. And so I think all that we're looking for is that the solar system that is there is really compatible and aligned with those best management practices.
Great. I think this is a prize rules question, but will the prize be limited to cattle and solar?
Sorry, say that again. Will the
prize be limited to cattle and solar?
Yes.
Yeah.
Short answer, yes.
Other than that, I think the rest are all can be found. The questions can be found within the prize rules that have been linked to. / we're answering some of those questions offline. But if there are any kind of technical questions that you either want to type in the chat, or if you would like to raise your hand and kind of come off mute and kind of talk about those questions, we greatly appreciate that at this time. Go ahead, Nina. I think you might still be on mute if you are talking.
Sorry, is that better?
Yeah.
Happy New Year.
Happy New Year.
Are there any examples out there right now of cattle around array that are not elevated?
So the vertical bifacial systems are not elevated, and there are a few examples of that. So that was some of the pictures that we had shown earlier. I have heard of some other sites, but I haven't necessarily seen pictures of them, where you do have cattle that are interacting and adjacent to non-elevated like single axis tracking or fixed tilt systems. But again, I haven't seen pictures. I've just sort of heard about them.
Would it be okay to do a mixture of elevated and not elevated? Like, does it have to be the same for your design, or can you do a mix and match?
I don't think there's anything wrong with exploring different configurations or different designs. I think especially as we think about trying to understand to what extent are cattle interacting with the panels at various heights or various spacings or what other configurations you might have. I think, you know, as we go back to the eligibility requirements too, which is making sure that if at least 250 kilowatts of those panels are where the cattle are interacting. So, you know, I could see something as long as you have that, but if you wanted to, you know, also test out and let the cattle roam or graze among shorter panels, you know, as sort of as an experiment or to see how it goes, how they interact. You know, assuming everything is done safely and with the best interests of the cattle in mind, I think that could be really interesting.
Thank you.
Totally agree. And just to add on very briefly, I think, you know, we are trying to figure out what is viable and what isn't, both in terms of design and in terms of management and business models. And that means that showing that something doesn't work is also valuable, just as much as showing something does work.
Great. Next question is, what percentage cost increase per project do you see for lifting up panels to accommodate livestock? And then we'll go to Dan after that.
Yeah, I would actually, I don't know if Brian or James, you'd want to take a first cut at addressing some of that.
Go ahead, Brian.
Cost increase for
Elevating
panels,
like up to 8 feet.
Yeah, I'm trying to. James, do you have that number off the top of your head? I have to look that up.
I believe at least some of the cost modeling that we had showed going from, I think it was 4 feet to 8 feet was about a 40% increase based on kind of costs, at least the initial cost modeling that we did. Now those numbers are currently being updated. And there were just a lot of different kind of considerations that kind of go into that. And particularly from kind of like a, you know, row spacing perspective, kind of like local wind loads, soil conditions. So anecdotally, we've heard kind of a huge range of costs, and it's really kind of been, I think, part of some of this prize is kind of about kind of data sharing in order to kind of answer this question specifically. But I think it like depends so much, but the modeling shows about 40% is probably the best answer I have.
And I can drop a link to that older cost modeling study in the chat.
And James, that's the equipment materials cost.
Yes. Mm-hmm.
Yeah.
Yeah.
I'll also say we've heard estimates in the range of a single-digit % increase in LCOE. So all costs, all in, a much smaller impact.
Yeah, absolutely.
And it's also going to depend on what the capacity is. So it could, you know, depending on if you're only doing a, you know, 500 kilowatt, because our cost study was only based on a 500 kilowatt system. If you're doing a 5 megawatt, 10 megawatt, 100 megawatt system, it'll be a different cost percentage. And as Bryn mentioned, yeah, then you also have to factor in sort of over the lifetime, many of those capital costs can be sort of muted by some other benefits you might get.
Great. We'll go to Dan.
Hi, can you hear me?
Yep.
Yeah, hello everyone. Question about size, and I probably know the answer to this, but We have a site which meets the, it's larger than 250 kW. But we, so we're in Oregon where there's basically two climates. You have the wet side, and then on the east side of the Cascade Mountains, it's dry. So we want to do replication on the in both climatic conditions. The site we've got so far on the dry east side is quite small, under 250 kW. So should we include that in, even though I guess it's not going to get counted towards the prize? Do you want to know about it in the application? Do you want us just to not even mention it, or how do you want to handle that?
We may need to think about that a little bit more. I think my initial thought is please feel free to write about it in your application. The more knowledge and information we can get, the better. Please, feel free to, and I'm going to volunteer you here, Jordan and team. I think please feel free to reach out to the Inspire team and talk to them about what it is you're doing and any information you can share. But yes, in terms of the prize, if you have a second site that on its own does not meet the size eligibility restriction and is sort of totally separate, that won't sort of count for what we're looking at in the prize, but we're definitely interested in what you're finding out from that replication in general.
Great, thanks. And if you know us, you know that we don't tend to color inside the lines. So
there's a few questions on here that that are kind of related, specific to foundations, and kind of like, is there any information available needed to strengthen the posts / kind of, are there any other specific kind of foundation considerations? I assume for the pilings on this questions that need to be kind of addressed for the cattle.
Yeah, our experience has been that the sort of the strength of the foundation and the piles and the steel, as long as you're building it towards the sort of the local, wind regulations and making sure it's able to withstand, whether it's 150 or mile-an-hour winds or whatever it might be, that has been adequate to an adequate strength to withstand any of the potential impact you might have from cattle. Because cattle will, what things that we've seen from existing sites, rub their backs, scratch their backs on the piles that are there, but it's really not of great enough force to have a major impact. And again, that's, I guess, what we've seen from the projects that have been built, really meeting the wind loading requirements has led to a strong enough systems to withstand that cattle integration. Obviously, that's sort of your day-to-day interaction of back scratching, things like that. But we haven't also seen or heard about any more aggressive behavior or anything else that would counter that.
Great. Next question. I think it's a couple different questions at once, so I'll kind of take the first one. The hardware is not UL certified, and is the recommendation from the LASSO team's rule about how to constitute the rest of the team? So that's more about kind of the teaming aspect. So I will say, in terms of the UL certification aspect, I know that that's often a requirement for actually exporting to the grid, and kind of getting insurance to actually kind of export, which I believe is a goal of this prize. So I think that's just going to have to be taken into account. I think as for the teaming, I don't know if we can kind of quite comment on that. Is there any other kind of things that you want to handle?
Yeah, just I think exactly right on the certification. There is not a specific rule about that in the prize, but grid interconnection is a requirement. on the team side, the team lead does not have to be a solar developer, but the team does have to include a solar developer and someone who is managing the cattle, a farmer, or a rancher is what we used in the rules. But the lead could be a different entity.
Great. There are two questions in here, mainly about engineering assistance available through the prize. I'll pass that back off to the team, and basically about kind of the kind of assistance for different kind of designs and non-traditional designs.
Looks like there's a question about body heat. And
That one too, yeah. I was gonna get to that one next.
gotcha.
But I think James was first mentioning the, to what extent we can provide structural engineering assistance. So I think theoretically, that would be in the next phase. So if that team is successful and moves on to the next phase, then there is, a set number of hours allocated to the team to provide specific, project team specific one-on-one technical assistance. And I think within that, most things are on the table. I think, Bryn, the only question would be if there are any limits on, like, if there's any limits on the topics that we can provide technical assistance on in that next phase for legal or liability reasons.
I want to make sure that I don't answer that question incorrectly, and not being a lawyer, I'm gonna hold off for the moment, but we will definitely try to answer these questions about assistance and what's available in writing as soon as we can on the website. And especially if you're following the website, you'll see any updates. You'll get a notification, I believe.
Yep, the only thing I'll add there is that at this time we can't talk specifically about some of the details of future phases that have not been written about in the current version of the rules that is posted, but I'd say your best bet is to keep an eye on HeroX as more information is released about future phases of the prize.
Great. Next question is, has there been any information if the cattle body heat impacts panel performance? I'll pass it off to the team.
And I hope that's a typo, Nina. I meant to say the crops can cool the panels, not cook the panels, right? So I think, yeah. So not that I have not seen any information about looking at cattle body heat affecting the PV panel performance. It's a very, very interesting question to think about. If you do have, a large group of animals, you're almost creating maybe a heat island, what impact that could potentially have and for what duration, et cetera. So that's an interesting question.
Yeah, it is definitely an interesting question to look at. I would imagine though that the body heat of cattle are going to be cooled by the panels. It's basically going to be close to ambient / like kind of the 100 degree mark, whereas the panels, when they're operating, oh gosh, it's been a while since my engineering days. I think they operate like much higher than that. So I would say that it's one of those. It's definitely interesting to look at. I think a lot of the research has been much more about the panel shading on cattle health and kind of like reductions. And we have not seen any evidence, even from sheep grazing or anything else, that there's kind of any impact. So it's something interesting to look at, but I don't think that there's been any kind of research or anything else like that done. The next one is much more, and this might be kind of a bit for the prize team and a bit for the technical team, but basically kind of the from the data bounty prize, kind of what are some of the metrics that you hope to see from this prize, and then are there any other measurements that you've seen taken in other systems that kind of might fit this. And so just kind of passing that off to the team if there's any kind of answer to that.
Oh yeah, Jordan, go for it. If there's things you're excited to see, I think this is your time to just request anything and everything you might want.
Okay, well, yeah, I mean, that's what we will do. No, I mean, I feel like in looking at what has been published, where is their literature available? I think two really big gaps that we're seeing. One is related to livestock health and animal welfare, and so thinking about, there's been a little bit, and some of the folks on this call have contributed to that. But we can look at things like breathing or heart rate or stress. All those sorts of elements that are really getting at are the animals, are the cattle benefiting from this. I think are certainly going to be of interest. I think another key area that we are interested in is related to soil impacts. So impacts on soil quality, compaction, sequestration of carbon, other sort of soil quality parameters, where the list is pretty lengthy. Those are areas where I think there's potentially, there's a lot of hypotheses that we have about both the impact of how agrivoltaics could impact cattle well-being, as well as the potential impact of the cattle on soil, both positive and negative impacts. And we haven't really seen that play out. And even, there's been more research related to sheep, grazing, but even that is, I think, an area that we feel like is a bit understudied, especially compared to how much deployment we have seen of sheep grazing under panels. And I think this is a really nice opportunity, especially as we do see, it's a really good opportunity to collect a lot of this foundational data on animal welfare as well as that soil area.
Just to jump in, another couple of things that we've thought about, perhaps that you could imagine collecting data on panel soiling, how much the animal interaction or integration kicks up dust or dirt that soils the panels, data on forage growth, health, quality, sort of the vegetation on the site, and the impact from the PV array and the cattle, as well as sort of a variety of detailed PV system, broadly defined data that might help shed light on how this integration might help or impact energy production.
I think something along the lines too of interactions over time, and that kind of like how do the cattle acclimate to this, and kind of the training method to kind of get them used to that might also be pretty interesting to kind of show.
And the body heat impact on panels.
Yeah.
Folks, we have one person with their hand raised. I'll go ahead and let them. It's Madison, and I will give them the permission. Madison, you may have to unmute.
Good evening, guys. How are you?
Good. Well, thanks.
My question is, basically, if we're working with city governments or universities for the land, do you guys look at the application differently if we're doing so on their behalf?
I'm not sure I fully understand. Are you asking whether we look at the application differently if the land is owned by a university or a local government?
Yes.
I'm going to take a second to think about that. I believe the answer is no. we want to make sure that the landowner is involved and a, you know, willing participant in this project, as well as the associated costs for using the land for these projects. And the only other, I think, relevant piece there is that we're looking to evaluate the viability of design and business models and the ability of those to sort of scale to larger sizes, to commercial operation, to other geographies. And so making sure that the design and setup that you have can address those things is important, but the ownership itself is not going to change how we look at the project.
Gotcha. Now, will there be a need for a 3D rendering for this project? And if so, who will provide that, or do we provide that on our own?
There is not a requirement for a 3D rendering of your site.
Gotcha. Thank you.
No problem.
Yeah, there were a few. It looks like we're at time, so I'll pass it off to Cameron here in a sec. It looks like there were a few engineering questions, but I think that can be solved with just whatever you need to kind of actually get a system up and running to a certain extent. And so I'll pass it back off to Cameron.
Thanks, James. Yeah, like James said, we are at time today, so I just wanted to thank you all so much for being here today. As we said at the beginning, any questions that we didn't get around to answering in the chat will be posted on our FAQ in HeroX. So keep an eye out for that in the next week or so, and we will also be posting the recording of this meeting as well as the slides. So if you have not followed the challenge on HeroX, that's a great place to start, and keep an eye on those resources that we'll be posting, and also go ahead and sign up for our additional TA sessions in the next month or two. So thank you again, and we will see you all later.